So today we're going to discuss linear functions. And so a linear function has a general form that looks like this. This is called the slope-intercept form. A linear function is a function that, for example, this could be my equation. And the highest exponent on a linear function is 1. So there's no exponent written, that it is understood to be 1. And whenever you have a linear equation, it has the graph looks like a straight line. So there's not going to be any curves. There's not going to be anything that turns around or is wavy. It's going to look something like this. It could go, the line could go up. It could go down, for example. And that's all going to depend on the equation. It also could be horizontal. So those are the possibilities of the different linear functions. There is a fourth possibility when we talk about slope. We're going to look at that next. That the slope of something could be undefined, and it's not a function, but this is another possible straight line, a vertical one. And we'll talk about that in a few. So, but back to my original. So I have y is equal to 2x plus b plus 3. And I said that in general, a linear function looks like this, where there is a value for m and there's a value for b. Those numbers are plugged in, they're real numbers. They can be positive, negative, they could be 0. And so a real number has to be in place of the m, and a real number has to be in place of the b. The m is the slope. So the slope is how fast the line rises or falls. So a slope can be like this, or it could be steeper, like this line, or it could be less steep, like this line. These all have different slopes. All three of these lines have positive slopes. How do I know they're positive from just drawing them? Because they rise from left to right, they rise, they go up. The one I drew earlier, this slope went down on this one at the bottom. This would be a negative slope, where this would be a positive slope. To calculate this slope, all you need is 2 points on that line. And what you do is you find the slope is the rise over run. It's abbreviated with the m. The rise is the vertical change. So the vertical change. That's the line's either going to go up or down. The run is the horizontal change. So how far does it go to get to the next point? And the formula to find the slope is defined as the change in y over the change in x. This triangle means the change in. It's the Greek letter delta. So our formula, if we have 2 points, you label the 2 points, x1, y1, x2, y2. and you find the difference in the y coordinates, divide it by the difference in the x coordinates, and you'll find the slope. And like I had drawn originally, there are 4 possibilities when you calculate the slope. It is possible that you get a slope that is positive. If the slope is positive, if it's a positive number, then the line will go upward. It is also possible that you calculate it and you get a slope that is negative. If the slope is negative, the line will go downward. The third possibility is that you calculate it and you get a slope equal to 0. If your slope is equal to 0, then it's a horizontal line. And to have a horizontal line, there has to be no vertical change. So it's 0 divided by some number. When you calculate slope, you'll get 0 divided by some number other than 0, and that will be a slope equal to 0. And the fourth possibility is that I calculate the slope and I get a number divided by 0, no horizontal change. And if that happens, then I have an undefined slope. And if you have an undefined slope, then you end up with a special line also, and that's called a vertical line. So those are the 4 possibilities that can go in place of this M here. And then what I have highlighted here in blue, that is called the y-intercept. So B stands for the y-intercept. The y-intercept is where the line crosses the y-axis or intersects the y-axis. And you can write B as an ordered pair. The x would be 0 because to be on the y-axis you have to have 0x as 0b. So in this example that I have here, we have it solved for y. The coefficient on the x is the slope. So I have a slope of 2, and I have a y-intercept. That constant by itself is the y-intercept. And you have to be in this slope, they call it a slope-intercept form. It's not a very creative name. Mathematicians are not creative. It's called the slope-intercept form. And slope-intercept form means it is solved for y. So if your equation looked like this, and I'm just making up an equation, this is not in slope-intercept form. It's still a linear equation, but it's not in slope-intercept form until I isolate the y and solve it for y. So we can't just take the coefficient on the x and say that's the slope, because it's not. And you can't just take the 7 and say, oh, it's a number by itself. It's the y-intercept. It's not. We have to solve it for y. And we'll look at a problem like that in a few. So what we're going to do now is we're going to use this information, the slope and the y-intercept, and we're going to graph. Because in ALEKS, you're going to be asked to do some graphing. And you're going to be given the equation, and you're going to be asked to graph it. So let's practice that. So I'm just drawing out my x and y axis, and I'm labeling them. And ideally, I would want to use graph paper. Just doing this a rough sketch here. And so when you go to graph these problems, the first thing you want to do is drop a point at the y-intercept. So the y-intercept is 3, so I look for the y-axis, it's the vertical one, and I put a point there. Then I use the slope. Now you may say to me, well, how can I use the slope to find the next point? Well, the slope here is 2. I'm going to write it as, if I don't have a fraction, I can write it any number as a fraction by putting it over 1. The 2 will be the rise, and the 1 will be the run. If it was negative, I would fall 2. So that means I'm going to rise 2 units and then run 1 to get to the next point. So I'm going to go from, and not from the origin, but from the previous point that I drew. So 1, 2, up, and then run 1. And now that I have my 2 points, I can connect those lines. I can also go backwards. So I can go over 1 and then down 2. And that would give me a little bit more accurate of a graph, especially since I'm drawing it on this whiteboard. And here is my graph. Now, when you're approaching these on the ALEKS, let me show you how you would graph on there. All right, so here's ALEKS, and we have this equation, y equals 1/4 x minus 4. So in this equation, the coefficient on the x is the slope, so 1/4. The number by itself is the y-intercept, and this time it's a negative sign with it, so I want to take the negative sign with me, and it would be -4. So I want to drop a point at -4 on the y-axis and then use the 1/4 to get my next point. So there's a couple ways you can approach this. I like to use this line tool, and I will place the point. You gotta be very careful. Place the point at -4, that's the y-intercept, and then you want to go up 1, and you're going to run 4, and you place your second point. So I'm just clicking to place the second point, and now that I've got the 2 points, this program draws the line for me. I wouldn't really use the pencil. The plot a point, you can plot the point, you have to give it the ordered pair and plot it, and then you'd still have to draw the line through it. This is probably the easiest way to use the ALEKS to draw the line. When you hit check, then it gives you the green light that you're done it correctly. So now let's go to another one, number 2. Here I've got a slope of -3 and a y-intercept at -2. So I'm going to place my y-intercept first, and then I'm going to go, this is a negative slope, so I'm going down 3 and run 1, -3/1, and then hit check, and I've got it correct. So just a brief overview of how to graph on ALEKS. Now, you can have, like I said, the slope could be 0, the y-intercept could be 0. If the y-intercept 0, then your y-intercept would be right at the origin, and then you find your next point and you graph the line. If the slope is 0, then you would have a horizontal line, like we discussed, and it would be horizontal, like this. So you would graph 2 points that run on that horizontal point that is necessary for that problem, and then it would draw the line. Also with linear equations, you could be asked for, I drew this graph up here, you could be asked for the x-intercept and the y-intercept. So this one has, I drew this green line, it crosses the x-axis at 2, so it has an x-intercept at 2. If you were asked to write it as an ordered pair, you would say 2, 0. If you were asked where is the y-intercept, you'd say here, and if you were asked to write that as an ordered pair, the ordered pair is 0, -1. You can also find the x and y-intercept and use that to graph the equation. So all you need is 2 points to graph any equation, and then you draw the line through it, and you have your graph. To find the x-intercept given an equation, you let y equal 0 and solve for x. To find the y-intercept, you let x equal 0 and solve for y.